All right, everybody, welcome to another Tech Chat Tuesday for Tuesday, August 15th, 2023. I'm Ken Rimple.
Sujan Kapadia.
And joining us today is Drew Rogers. Hello, Drew.
Hey, well, good to be here.
So we're going to bring Drew in a few minutes. He's going to talk to us about DevOps and CloudOps. Just before we start with that, I want to talk a little bit about some of the stuff that we have on our website. So let me just go to Chrome here. That's the one. And we can briefly discuss. So if you go to cherrysolutions.com, there's our website. You can find out more about us. If you hit our blog, we have a lot of good information recently in the blog. We always do, but there's a lot of good stuff recently. So for example, Keith Gregory, one of Chariot's AWS and cloud experts and data engineering people, has been doing a lot of research around the data engineering features, such as data pipelines. So for example, we were talking a bit about Redshift. He's been doing a fair amount of Redshift writing. Also had a webinar on that as well that is available to look at online. And then after that, we have a couple of articles that I had done around REPLs and Electron and things like that. But he then continued with one on Postgres. So Postgres for data querying as a possibility. And then also small data, like what do I do when I don't have a ton of data, but I have to do decision support? What are some of my lower cost, low latency decision support options there? So there's a lot of good blog articles. Specifically, Keith has been doing a lot of really good ones around the data side of the house. So check that out, cherrysolutions.com/blog. And the big story also is that we have just released all of our videos for Philly Emerging Tech 2023. And so there's a playlist. You go to youtube.com/chariotsolutions. That'll take you to this link. And you can see the full playlist for all of Philly Emerging Tech. And there's a lot of really good talks here. Just a lot of good technical dives into, everything from front end stuff to, distributed systems and telemetry to data workflows with things like DBT, talking about, our keynote Choreo Robotics, where we got robots, or basically Katie Kwan got robots to kind of dance and interact with each other and interact with people. It's a really interesting keynote. So a lot of really good stuff here. Check it out at youtube.com/chariotsolutions, and you'll see the Philly ETE 2023 playlist. All right, but we have ourselves here today because we have Drew Rogers, a Chariot person. How long have you been at Chariot?
2011. So wow. Yeah,
12 years.
I think Sujan the same amount of time.
Yeah, see, there we go. So first of all, so Drew, why don't you tell everyone what you do here at Chariot, just to kind of set the stage.
So I'm a sysadmin here at Chariot Solutions, and also a DevOps/SRE consultant for clients. So, and I started out just as sysadmin, and I moved to consultant work the past couple, I think 5 years now.
And so for the last 3 years, you have been working on a client doing a lot of DevOps and CloudOps and SRE stuff, I guess, for them. And we thought we'd bring you on to kind of talk about some of the challenges you ran into and some of the things you've learned in your journey and stuff you might want to share as advice as you kind of go along with this kind of work. So let's talk a little bit about that. So this is a sports betting industry client, correct?
Yeah. Started out sports betting. Very interesting work, very fast-paced. Competition's high, so always using emerging tech. So it was actually really, really fun project for the past 3 years.
Okay, so let's kind of set the table then. So you get on this project, and like the first major challenge you ran into. So there's something about dealing with like data in one location, you had to move it, right? So what was the story behind that?
So dealing with in sports betting, there's a lot of compliance issues within countries and jurisdictions within the countries that are changing a lot. So at one point, the client was in all their infrastructure in AWS was in Europe, and at the point where I came in, as one of my major projects was there was no more red tape that that the client had to be in Europe anymore, so they wanted to come back to North America. So my main project was to use their Terraform that was constructed to build infrastructure in Europe, make it so that we could transfer everything back to North America, and at the same time make it region aware and make the app have the ability to be multi-regional. So in this aspect, it would have been moving from Europe to US East 1 and US West 2. The kind of the interesting things were that making a app region aware that wasn't region aware in Terraform is a lot more work than I anticipated. Some things like just IAM names. IAM is a global scope space. It's not region. It's global. So you can't have the same name in your whatever environment AWS account you're using. So that just like a lot of these kind of hiccups here and there really popped itself up. But using Terraform, it was pretty straightforward. You just make kind of things that are in the global scope region aware, and make some changes here and there, and then just apply the Terraform in the other region and start spinning up.
Okay.
What can you talk a little bit about like the actual process of doing that and testing along the way? Like how did you actually perform tests and then say, okay, we promoted this eventually to prod? How did that work?
So it was easy, obviously, to do a non-prod. So kind of working all the way at the bottom in the in the dev environment. We had a lot of modules, Terraform modules to spin up, and then kind of making a run book on how to take a brand new environment and spin it up using modules in a hierarchical kind of step-by-step basis, because a lot of modules use dependencies on other modules. So testing was pretty easy in dev, because once we spun up dev, we could have developers actually just deploy to it and use it. At this point, we had CI/CD develop and push to both environments, the European environment in dev and the North American environment. So we could come back and make sure all these environments are actually like working and good to go. Production obviously was a lot harder, because production is a lot more compliant. So I actually could not do it because I don't have a gaming licensing for all the jurisdictions. So legally, I cannot touch anything production. So so people that actually had licensing can actually push the run books once we got into the production environment. And testing was actually pretty straightforward too, because the client had a blue-green environment. So we actually had the non-active environment used for GLI, which is the gaming and licensing for each jurisdiction, as well as QA able to run smoke tests on the non-active environment, which was actually in North America. And then once everything was good, we just flipped the switch in DNS.
Nice.
And it was about 15 minutes of downtime just because we had to wait for marketing and things, and then DNS to actually like populate around the world to actually look at the new stuff, and everything was good.
Was this like a code-free scenario, or were development teams continuing to develop as this was going on?
So yeah, so it was so every time there was a release, GLI forces a code freeze for all environments that they're doing testing on. So code freezes actually in sports betting seem to last a lot longer.
Okay.
They could be 2 weeks to a month, because
Oh wow,
because a lot of all the jurisdictions. So if it's not just one entity, it's New Jersey, Pennsylvania, New York. They're all doing their own testing, and then we have to freeze.
So to be more specific, I guess you mean like code freezes mean merging to main line is frozen. They're continuing to develop on other branches.
Yeah, at this point, it was only the development branch, and then the next stage would be local testing, which would be frozen at that point for local QA, and then at the same time they would push to different environments for different jurisdictions.
So I'm sure you felt like there must have been some pressure around this, right? In terms of like, we need to cut over by this date. Was it pretty intense having to do that?
Yeah, some jurisdictions, I won't name the states, but some jurisdictions were hardline. If it's not in this date, we have to rework all the getting the people ready for testing, people in the field ready for testing, things like that. So it was a lot of pressure. Yeah, definitely.
Okay. Wow. So, I mean, obviously I'm assuming that it's, in addition to Terraform and making modules region aware and having that information flow through to each of the Terraform modules in your files, it's not just a one-to-one move something over. There must have been, you mentioned that you were going on that journey to making things multi-regional. So in addition to Terraform and infrastructural changes, I'm assuming there were architectural changes as well to support that.
Correct. So a lot of the AWS managed services, so a lot of them had to be changed. The client was using RDS, was using a Postgres just instance with read replicas. Obviously, that's not going to work in a multi-regional scenario. So we changed it to use Postgres and Aurora in a global cluster, and we had read replicas in US West 2, have the active region US West 1 for primary. And that actually helped us a lot with migrating from Europe to North America, because once you turn on the global clusters, the regions sync together, you have all the data you need. Some schema changes had to be made, mostly for authentication, things like that. But it was pretty much very minimal we had to do to make sure the European data was actually synced up and pushed into North America.
Okay, so basically you brought up the cluster, you moved over the data that was in RDS Postgres in the European region into Aurora, and then from that point is synced across the global cluster.
Yep. So during the 15-minute outage of migration, that was the last push of incremental data that was not in Aurora. We finished that, turned the European database off, Aurora on. It had almost 99.9% of the data already there, so it was pretty minimal downtime.
That must
it worked great.
Feeling when after that 15-minute window, like, yes.
Yeah. Yeah, data. So the funny thing was, obviously, we're monitoring usage, and as soon as DNS was propagating, we saw bets immediately in North America. Like almost like people were just like refreshing, ready to hit those slot machines, ready to hit the parlays. So it was pretty funny, and like immediately, just like bets for just all jurisdictions were just flowing straight in. It was great.
Yeah, that's like mission control. Like, yes, we've the successful landing.
Yeah, it kind of like that when we saw the first bets coming in. A lot of people in the war room. I mean, granted, this was like 3 a.m, so we're all a little bit tired, but yeah, it was like the Eagles landed kind of thing. It was nice.
We made it. Yeah. So the other part of this, obviously, so you're moving things from location to location, from region to region. Talk a bit about like the way the applications were run and how that went over time. So I understand you started off, the platform was on ECS, which is basically a Docker fronting system on AWS. Tell me why. I know you know Kubernetes as well. Tell me why like ECS may not be like as controllable or configurable necessarily as EKS or Kubernetes itself.
So, so the back end and a lot of the other dependency services were all in ECS, and it worked well. There are scenarios where the client or the jurisdictions would want us to use certain services. say for like Waza, which is like I think it used to be called OSEC, but old security service for Linux.
Mhm.
And in the ECS world, it's not straight Kubernetes. Like you can't just Helm
Right.
install. You can't just there's no operators. You have to design your task from scratch. So if you want like a daemon set for Datadog, a daemon set for whatever security you need, you're going to have to kind of make it yourself. Um, so that became and this was like not just two. This was becoming a problem. So
Mhm.
during the migration, after the migration into North America, and everything was pretty much stable, one of our next milestones was moving to EKS. So one, we could have the stack running in Kubernetes, almost like it is in ECS, but you have just way more leverage on services that you want to install, or and how you want to do uh, application like HPA, uh, so I'm trying to think of the word, the scaling up, like HPA
Okay.
scaling, things like that. Like
Mhm.
ECS, you do have control of that. If you want to do a more robust scaling, ECS is only going to take you so far. So
For
just
example,
things like
Yeah.
oh, go ahead. You're okay.
just things like that. So
Mhm.
we decided to move to EKS, and so now at that point, once we have the stack running in Kubernetes, we can install whatever operators we want. Datadog, like monitoring operators, metric gathering, services for data engineering, like PG Bouncer. Like we had a PG Bouncer front end for Postgres to
Mhm.
handle connection pooling. A lot of that becomes much easier because you're either running off Helm files from the third party providers, or the operators, which is a lot easier to customize and handle than like Helm files. So you have all the, and then also you have complete control of scaling. So like using an operator like Kata, you could use event driven scaling instead of just scaling on CPU and memory. So,
Right.
and then at the same time, if you ever want to move to another cloud, it's a lot easier, which we actually did do.
Yeah. I was gonna
So,
say it kind of came in directly handy for that.
correct
Yeah.
me if I'm wrong, because a lot of the Kubernetes stuff is terminology is new to me. But it sounds like what you're saying with Kubernetes is it's much easier to configure the environment around which your container is running in than in like ECS or just using Docker and Docker Compose.
Yeah, so like ECS, you're basically making pods. They're called task deployments, but they're pods,
Okay.
and you have zero control. You have zero access to the control plane, and things like Helm don't really work too well. So yeah, so once you get into Kubernetes or like EKS, even though you don't have full access to the control plane, you have access to all the bells and whistles that Kubernetes will give you, and then you could highly configure the environment running the pods more than you can in ECS.
Interesting.
So it's a more open control plane that you can, hook into to add all your these operators. So operators are kind of like running containers that manage the infrastructure that can communicate with Kubernetes, like control stuff and stuff, things like that.
So as an example, like you mentioned connection pooling is one. Would another example be like a log aggregation agent?
Correct. Yeah. So
Okay.
Datadog has an operator. So yeah. So to answer your question, Ken, you could have a Helm chart that is basically giving you manifest for Kubernetes on how to install each manifest and configure it through environment, through variables, through whatever. Operators the same way, but it's actually controlled by the operators actually has agents controlling what they want their other stuff to do. So like if a company like Datadog it makes an operator, they could have it do a lot more things than just giving you a Helm file.
Interesting. So it sounds like these days a lot of these other services you're talking about in companies like they play much better with Kubernetes, and that's where the mind share is. And companies are building operators, et cetera, can Helm chart file. Sorry if I'm using the wrong terminology here.
No, you're correct. You're absolutely right.
It sounds good to me.
To work with
they're
Kubernetes rather than like just plain Docker, for example.
Yeah, because like, I mean, you can, like, a company can give you a task definition in ECS, and it only could go so far.
Mhm.
You know, and then so in the Kubernetes world, like, yeah, so companies are straight up just making operators, and you know, once you buy into whatever ecosystem you're getting yourself into, they'll give you the operator how to, you know, the access from the operator to
Okay.
Kubernetes or to whoever third party, and then the operator is actually running in its own namespace and then controlling other namespace. Usually, whatever the operator actually does, but it's controlling the environments,
Mhm.
whatever the operator is doing.
And sorry to go on. I know we're going a little bit on a tangent here, but this actually is really interesting.
Yeah.
Have you been in a situation where you actually the company, like a development team within the company or an SRE team, they're building their own operator to, you know, because there's a service developed within the company that now can live alongside within your pod. It's not an application service, but it's like a, you know, a background service that you need to do something. Have you built your own operators before?
So we were actually planning on building an operator. They're definitely usually especially when we're doing our own thing. If you're using like a GitOps workflow, Helm is going to do everything you need to do. There's other template configurators like Customize and things like that, but usually Helm would do it. We actually were thinking about making our own operator for something that may be used within other Kubernetes clusters,
Right.
Like data engineering wanted something that would scrape metrics in different scenarios and then pull them all together. Helm at that point was just a much easier thing to do. Helm worked great for that, and we didn't need to do. But we were actually thinking about making our own operator.
That's pretty interesting.
So can we dig in a little bit then, since we're nerding out on Kubernetes, and let's talk a little bit about, for people who don't know, which would be not me, us. You were mentioning GitOps, and I think we were talking earlier in the pre-interview also about Argo. So some of the tools around this process. So can you explain GitOps to people in terms of what that is?
Yeah. So Kubernetes always kind of had a continuous delivery-ish problem. None of the old GitHub the DevOps tools like Terraform they didn't really work too well when it came to pushing changes into Kubernetes itself. It does fine making the infrastructure that actually runs Kubernetes, but once you get into the point where, okay, now that the infrastructure is set and you're deploying changes in Kubernetes, Terraform and other tools didn't really work too well. So I think a bunch of services like Flask and Argo CD came out, and they made it so your single point of truth for only stuff running in Kubernetes lives in a Git repo. So then at this point, you could have a nice Git flow on making changes running in the Kubernetes. You make your changes, you do your PR gets reviewed, merged, and then Argo CD, which is running inside Kubernetes, will look at your single point of truth, look at what's running live, and then make sure everything's synced. And if it's not, it will let you know, and then you could completely build a whole pipeline on top of that.
And that is completely, like, whether you were using was it the EKS or using Kubernetes somewhere else, you can still use the same workflow.
Yeah, so
that's a benefit.
A nice scenario that our whole GitOps workflow worked very well was when we were moving from EKS to GCP Kubernetes service.
So Google Cloud Platform for people following along, right? Moving from
Correct.
AWS to Google in this case.
Yeah. So the nice thing was we we use Terraform to build up the GCP side for all the infrastructure running Kubernetes in Google Cloud Platform.
Mhm.
And then we just added those clusters to Argo CD. And when we were ready to kind of like spin down the old AWS EKS cluster and spin up the new GCP cluster, we just added the clusters in Argo CD, sync them, so all the apps just spin right up. Kind of make some changes here and there for like persistent storage and how some environment variables need to change. But other than that, spun right up and changed DNS to point at the new cluster, and everything worked great. It was really nice to see because you could imagine for sports betting, there's a lot of deployments and services spinning up in Kubernetes and to watch them all come up pretty easily was pretty awesome.
I think that's one of the interesting things about the whole cloud world we're in today, right? So I'm just going to philosophize for a second. It's my own idiotic thinking on this. But, you look at like AWS and you've got these millions of managed services, millions is a complete, exaggeration. But you got all these managed services and you've got that's one of the things they bring to the table is a ton of those things. But if you commit completely to manage like backplanes and services like an ECS or what have you, and you do have the need to run this on multiple clouds, that's really a challenge because you have to go look for the same type of thing in another cloud platform, and they're not going to be the same API. They're not going to be the same configuration. But it's really cool that there are these tools out there. If your shared thing is Kubernetes, then you have transportability of at least your application services for sure.
Correct.
That's a big finding, I think, from this whole process.
Well, yeah, that seems like everything is going towards supporting Kubernetes.
Yeah.
Yeah, and also to expand on that, when we were moving from AWS to GCP, obviously in AWS we had all the databases and we're running in RDS. They had Elasticsearch running in AWS, and obviously the pain points of migrating to GCP, because at that point things are very different, and the engineering and the DevOps teams had to kind of figure out how to get RDS working in GCP exactly the way it was in AWS, and same thing with like Elasticsearch and Redis.
Sure, yeah.
To the point was a little bit before my contract ended, because of that point, the client moved their database out of managed service and into Kubernetes. So at that point, you could remove the whole making sure where your database is. Well, no, it's in Kubernetes, and that becomes very portable as well and very managed for other operators to manage your database, which they did do.
Okay, so I guess the trade-off there is now you're something or someone's or some team is managing that database and replicating and scaling and snapshots and backups, et cetera, versus a managed service taking care of a lot of that for you.
So we did have a managed service. It just wasn't the cloud platform. It was another service that another operator that
got it.
that actually they handle all the how the database gets replicated, how masters get failed over, how to handle persistent storage.
That's interesting. Okay.
Another thing about sports betting is the laws are changing all the time in each jurisdiction. So it seemed like whatever third party we're using for some jurisdictions wasn't as strict as they was maybe when I first started, but they still have to be approved though. You're right. We can't just use whatever we want.
Exactly. Yeah. So that makes that process harder, right? Because you got to make sure that is there because you want your data to be safe, et cetera, versus knowing, okay, this cloud platform is approved. Then you don't really have to worry as much about using managed services with the cloud provider.
Yeah, and it's tough. Some jurisdictions will all of a sudden say like, oh yeah, by the way, anything that touches the app, they have to fill out our tax paperwork, and then all of a sudden we have to go to like 25 vendors and be like, well, this jurisdiction says you have to do this. If the vendor says we don't want to, we can't use them anymore, which happened, and it happened for our CI/CD pipeline for certain services that we had to change from for where we store Git source. Like,
Wow.
and a lot of that happens. Like all of a sudden, it's like the jurisdiction's like, oh yeah, by the way, if you don't have this, you can't have anybody gamble in our state. So
Wow.
So can I ask a question? So you mentioned there's some other services that you had to move over, like, or I'm not sure how much you were involved in, but like things like Redis and Elasticsearch. So from a Redis perspective, like you were also like making sure that that was available globally, correct?
yeah, so that was a part of our migration from Europe to North America, and at the same time making the app multi-regional. Yeah, so we obviously uh, nothing can be like mostly nothing can be local to the region, especially when it comes to like obviously database. So Aurora fixed that problem. That was easy for us. Global Redis caching was actually a lot harder on the back end team. Where at the one point they said, "Well, listen, we're not ready for this," and so we changed from being multi-regional to being a hot cold standby, and we were really running in US East 1, having US West 2 as okay. It became like a standby region in case like a meteor hit Virginia or whatever.
A lot more of an issue if a meteor hit Virginia. But
Yeah.
yes. Wow. So okay, okay, so in that case, are you running Redis in another pod, basically? Did you
No,
move
this was managed service at this time. It was
Okay.
in AWS. Yeah, and
Mhm.
AWS had at this point it just became available when we were actually doing the migration
Lucky break.
Redis had a global a global cache feature where it could sync between regions. It's just we actually never used it.
I'm sure
So it's
anything
yeah.
global probably costs a pretty penny.
Yeah,
Oh,
I
I'm
think
sure.
so.
Yeah. So
Especially
tools
if
of the
it's like
trade then.
Elasticsearch or Elasticsearch already. Yeah, Elasticsearch. I'm not sure if their service has like a global feature, but yeah, that would be a lot of money.
Yeah. So then tools of the trade that you really honed in then were obviously Kubernetes, getting really good at your Kubernetes configuration and understanding how to install operators and configure them and what to apply. You also were dealing with Terraform a lot, and you were using GitOps with Argo. Are there any other cool tools that you ended up using or techniques that you really like picked up here that you're like, wow, I'm gonna take that everywhere?
Absolutely, yeah. So I would say scaling was something that surprised me, and how um, once you enable event-driven scaling in Kubernetes, um, you could really start making some scaling policies a lot better than just waiting. Traditional scaling is all of a sudden you have an influx in users, and then your CPU goes up, and then your
Yeah.
pods scale up. That's kind of
Reactive.
like it's
Yeah.
very reactive. So when we do event driven, we could get predictive, and then that helped us
Mhm.
with sports betting. Is very so the app can handle sports betting obviously, but it also can handle casino gaming.
Mhm.
So you have to be able to have reactive scaling for things like you never know. For some reason, it's Saturday night, and a lot of people want to play slots.
Mhm.
So all of a sudden, you have to start scaling up for aspects like that. But also, sports betting is very not predictable. So during the NFL season, uh, our the utilization for our app skyrockets for the NFL. So uh, instead of just being reactive, we could have events running inside whatever monitoring metric service we're using, Prometheus, Datadog, to actually start scaling up using predictive data for like anomaly things like that. So
Hmm.
we don't have to do the whole manual. Okay, it's Friday, let's scale up Friday night, and then Monday morning comes, let's manually scale back down. You could have events that actually drive the scaling, and you don't have to worry about it. Or you have predictability where you have something that you may not know, but because it's event driven, it's you have a scale of event that you might not be aware of, which is nice.
Mhm.
That's interesting. And that's what you were mentioning, like, moving from ECS to EKS, for example, in terms of like I guess a bog standard AWS ALB, you're limited in the types of things you can scale on. Whereas with Kubernetes, and you mentioned earlier, event-driven scaling, you can do a lot of custom logic, it sounds like.
Yeah, and even so, this is like HPA pod scaling. But then again, you could have interesting strategies in node scaling. So in ECS, you have traditional node scaling. You have a CPU threshold that the average, all the nodes are
Right.
reporting as an average, and then if that crosses a threshold, it starts spinning up new nodes. Sometimes that doesn't work, especially if all of a sudden your app gets hammered, right?
Okay.
And then your ALB will take some time to actually report that and be like, oh, okay, let's start scaling
Spin
up.
up. Yeah.
And then the scaling happens, and then the node has to join the cluster, and then the scheduler has to push pods. So that takes some time. So in EKS, there's some operators that you could have a threshold of cold standbys that the operator actually controls. So as your app's scaling up and as your nodes are scaling up, they scale extremely quickly because the operator would say, oh my God, we're getting hammered.
Yeah.
These 10 nodes, turn them on, schedule
online.
starts, and the schedule will start pushing pods to those cold standbys. And then the operator itself will start building new cold standbys. So there's no lag time between the nodes building
Instead
up.
of pooling and asking, hey, are you healthy or not? I need scale. The thing's telling you, no, hey, just go scale up. I'm telling you, I'm going to die.
I'm being hammered.
The operator actually cordons the cold, meaning that they're available, they're in a healthy state, but the schedule is not allowed to push deployments to them.
Right.
So once the operator says, oh, we're getting hammered, like we have to start scaling, it just turns the schedule, it turns those nodes on, say, okay, we can be scheduled, pods just get flooded in there immediately. And then at the same time, the operator's like, okay, we don't have any more cold standbys, let's start spinning up some nodes.
Wow, that's wild. It's really a
Yes.
lot more sophisticated than what you get. Plus, I mean, in the time where ECS is saying and checking all this stuff, you could have completely saturated those nodes that are running, which is kind of, I think, your point there.
At the same, the same time, there are a lot of managed case for ECS. If you don't want, because obviously with all these operators, your blast radius for Kubernetes can be pretty big. You never know if for some reason if an operator is not configured right, it could bombard something that impacts other things running in Kubernetes. So I see if you're just running a couple of Docker images, if you just want to run it in some sort of orchestration that's, you have basic scaling, but you don't want to run anything else, no daemon sets, no whatever. ECS is perfect for that.
It's fine for that, yeah. But for something serious where you've got lots of traffic and it's unpredictable and you want to be able to really react quickly to pressure in load and things like that.
Yep.
It sounds like you want more options.
Yeah, if you want more control over your environment, yeah, Kubernetes is definitely it.
Cool. Any other tools that like you could think of or techniques you could think of from that?
Yeah, Lens. So I mean, connecting to Kubernetes is a very important tool to have, and I always use K9. K9s is a tool in the command line that really makes connecting to Kubernetes and like editing manifests, like troubleshooting really. Like the one thing you want to do is make sure you know how to troubleshoot quickly in Kubernetes, because a lot of things, when things go wrong, you may not know where to look. So having a good manager helps with that. I always use K9s, but there's an app called Lens that makes troubleshooting in Kubernetes a lot faster, which is great. So if anybody needs help connecting and managing Kubernetes, I would suggest either K9s or Lens.
Cool. All right. Do you have any more questions, Sujan?
No, I don't know if you guys covered this while I stepped out for a second, but I think just to recap, putting the Chariot hat on, I see a number of things here that Chariot can help, other clients with in terms of, multi-region aware application workloads and infrastructure, Terraform, refactoring, Kubernetes, GitOps, migrating across different cloud providers, sounds like you have a lot of experience now, Drew, also like working with engineering teams along with these migrations, right? The blue-green deployments, testing, having to help figure out what new services map to the services they were using in a previous cloud provider. It sounds like that obviously takes a lot of close cooperation with the development teams. You can't just kind of do that and throw it over the wall.
Yeah, and GitOps really makes the visibility to the back end, front end engineers, like they're actually a part of the deployment process. They actually are a part of the getting to know what's running in Kubernetes and how it's running. Kind of like how Circle CI and GitHub's Actions kind of like makes the CI/CD deployment transparent to the engineers. So GitOps does the same thing. Now, I think Kubernetes doesn't become like something where the engineers are like, I don't know what's running in there. But now because of like GitOps, they're actually aware of the whole deployment process and how actually things run in Kubernetes.
Yeah. So, it sounds like Kubernetes has a lot of flexibility, customization. A lot of the vendors and other services out there play well with it now. So, I get if you're listening out there and need help with scaling your existing infrastructure or moving to something like Kubernetes, if you feel like there could be benefit to move towards there, GitOps, et cetera, certainly reach out to us. We'd love to chat and figure out ways that we can kind of assess where you are right now and how we can help move you along.
And also transparency into what's happening in Kubernetes. Shipping data to like an aggregator like Datadog and monitoring it is very important in Kubernetes. A lot can go wrong. So one of my humongous projects was making sure monitoring was working well in from ECS to EKS and then to GCP's Kubernetes service. Making sure that if a pod's crash looping, if persistent storage is failing somewhere, right away, where to go, where to look immediately, instead of taking hours to just find out what's going on. So transparency and monitoring is very important too.
Awesome.
All right. Well, thank you, Drew, for this. This is a great conversation.
Sure.
Really learned a lot that I know I don't know now.
Exactly.
That I'm going to talk to you about.
I'm just thinking of the number. I'm like, there's Terraform files, there's Helm charts, there's the Argo CD. Like they're just drowning in configuration files.
Yeah, and it just keeps growing.
Yeah.
Well, thank God it's in Git now for PRs.
Yeah,
that's right.
That doesn't hurt.
Yeah.
All right. Well, thanks again, Drew, for being on the podcast, and we'll see everybody in a couple weeks.
Thank you.
Thank you so much.
Thank you.
Bye.